The People's Pharmacy podcast is supported in part by CocoVia. CocoVia cocoflavanols support both cardiovascular health and cognitive function by promoting healthy blood flow. That transports oxygen and nutrients to vital organs and muscles, including your heart and brain.
CocoVia now comes in an even more concentrated formula with 450 milligrams of cocoflavanols, 5 times more than the leading dark chocolate bar and 15 times more than the leading cocoa powder.
CocoVia has a proprietary process that preserves cocoflavanols at the highest levels. The product undergoes rigorous testing at every stage to guarantee the highest level of cocoflavanols per serving and to provide the purest, highest quality product possible.
People's Pharmacy listeners can now try CocoVia for 25% off by using the code PEOPLES25 at cocovia.com. Antibiotic resistance has become far more common than most people realize. It means that some infections can't be cured. This is the People's Pharmacy with Terry and Joe Graydon.
When Tom Patterson came down with an infection that was resistant to all known antibiotics, he went into a coma. His wife, Dr. Stephanie Stradley, made a desperate last-chance attempt to save his life with viruses culled from sewage.
Such bacteriophage therapy has been used in Eastern Europe for nearly 8 decades, but it's almost unknown in the U.S. Now, researchers are reviving phage therapy on the principle that the enemy of my enemy is my friend.
Coming up on the People's Pharmacy, find out how bacteriophage therapy can kill superbugs.
First, the news.
In the People's Pharmacy Health Headlines, Dr. Anthony Fauci, head of the National Institute of Allergy and Infectious Diseases, told Congress this week there's no guarantee we'll have a safe and effective vaccine against COVID-19. He also warned that failure to control the virus with effective physical distancing, hand washing, and face covering could lead to huge numbers of Americans becoming infected. He cautioned the legislators that up to 100,000 people a day could catch the coronavirus if they don't follow the guidelines. In addition, Dr. Scott Gottlieb, former FDA commissioner, estimates that half the U.S. population could become infected before the end of the year.
A large drug trial has been restarted to see whether hydroxychloroquine may help prevent COVID-19 infections. The study will recruit 40,000 healthcare workers internationally. They'll receive chloroquine, hydroxychloroquine, or placebo before being exposed to patients with COVID-19. The research was halted temporarily following the publication of results from previous trials that suggested the drugs increase the risk of heart rhythm disturbances. However, that study was retracted because the database on which it was founded was not open to audit. The lead investigator of the study is hopeful that hydroxychloroquine might be able to prevent healthcare workers from catching the disease, but only this kind of randomized controlled trial can tell us for sure.
Is there another pandemic lurking around the corner? Researchers have reported that a new swine flu circulating in China has made the leap to humans. It's called G4EA-H1N1, or G4 for short. A study published in the Proceedings of the National Academy of Sciences reports that roughly 10% of the swine workers who were tested came up positive for G4. So far, though, there has not been human-to-human transmission of this influenza virus. Nevertheless, the authors state that this flu strain possesses all of the essential hallmarks of a candidate pandemic virus. They continue, it is of concern that human infection of G4 virus will further human adaptation and increase the risk of a human pandemic. In the midst of the COVID-19 pandemic, people may have forgotten that there was an influenza pandemic in 2009. That H1N1 virus also came from pigs, and G4 seems to be descended from that strain.
Looking for a healthy snack? Researchers published the results of the ATTIS study and found that eating whole almonds as a snack improves the flexibility of blood vessels and lowers dangerous LDL cholesterol. More than 100 individuals at above average risk of cardiovascular disease participated in the 6-week trial. 51 were assigned to whole roasted almonds and 56 to munching mini muffins as a control snack. The snacks provided the same amount of calories, approximately a fifth of the daily total intake. There was no effect on weight or waist circumference, but the improvement in blood vessel response was very encouraging. The investigators estimate that consuming whole almonds instead of other snacks could lower the risk of cardiovascular disease by about 30%.
Researchers have been disputing the benefits and risks of moderate alcohol consumption for decades. Some studies have suggested that several drinks a week might be beneficial for the cardiovascular system, as well as the brain. Other research has been less supportive. A new study involving almost 20,000 older Americans lasted almost a decade. During that time, women who consumed fewer than 8 drinks a week and men who consumed fewer than 15 had less cognitive decline than those who consumed none. They were tested on things like word recall and vocabulary. Unfortunately, this benefit was only observed in white participants. For Black volunteers, there was no association between moderate alcohol consumption and cognitive health. In addition, the scientists point out that drinking more results in worse outcomes for brain function. These results are strikingly similar to those found in a study from South Korea just a few months ago. In that research, scientists found that moderate drinkers did not have evidence in their brain images of degeneration specific to Alzheimer's disease. And that's the health news from the People's Pharmacy this week. Welcome to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon. We'd like to apologize for an error in last week's show. The wrong interview aired in the last segment. Listeners who would like to hear our entire show on how industry manipulates science, plus an extended interview with our guest, will find it at peoplespharmacy.com/podcasts. You can also find our podcast on Spotify, Apple Podcasts, Stitcher, Google Podcasts, or your other favorite podcast platform. Just search for The People's Pharmacy in your podcast app. This week, we're discussing how to overcome infections with multi-drug-resistant bacteria. Patients who contract such infections are in mortal danger.
Dr. Stephanie Stradi was faced with just such a situation when her husband slipped into a coma due to bacteria that failed to respond to any known antibiotics. Dr. Stradi is Associate Dean of Global Health Sciences and Harold Simon Professor in the Department of Medicine at the University of California, San Diego. She's co-author of The Perfect Predator, a scientist's race to save her husband from a deadly superbug.
We'll also hear from Dr. Saima Aslam. She directs UC San Diego Health's Solid Organ Transplant Infectious Diseases Service.
Welcome to the People's Pharmacy, Dr. Stephanie Stradi and Dr. Saima Aslam.
Hi, it's great to be here.
Thank you very much for the invitation.
Dr. Stradi, let's start with you, if you don't mind. Can you please tell us the rather extraordinary study of your husband, Dr. Tom Patterson's life-threatening drug-resistant infection? And this happened while on vacation in Egypt a few years ago.
That's right. My husband and I were on vacation, and he acquired a superbug infection. It's Acinetobacter baumannii, which is commonly referred to as Iraqibacter because so many vets come back from the Middle East with this infection. And he didn't know it at first, and neither did I. He actually had a gallstone attack, and we ended up at a clinic in Luxor, and he started to really deteriorate very quickly, and we got him medevaced out of there to Germany, and that's where they realized that he had a giant pseudocyst in his abdomen the size of a small football, and inside it was lurking this organism that a couple of days later came back as Acinetobacter baumannii, and it was almost fully resistant when they diagnosed it there, but by the time he was medevaced home to San Diego, it was resistant to every antibiotic under the sun.
How was he doing? I mean, that sounds life-threatening.
Well, he was in and out of a comatose state in the beginning, but we did manage to stabilize him. And there was a question as to whether or not they were going to operate and try to remove this cyst. But when they realized that they didn't have any antibiotics to cover it and that he could, die of septic shock, they decided to do a procedure with interventional radiology where they poke holes in his abdomen and basically try to siphon off the fluid with catheters. And that seemed to work for a couple of weeks. But one day, in fact, it was the day before we were supposed to get out of the hospital, he sat up in bed and one of these internal drains inside him slipped and it dumped all of that infected fluid into his abdomen and he immediately went into septic shock right before my eyes and rushed back to the ICU and was dying from that moment onward. It was just dreadful.
And of course, as you said, there's no antibiotic that actually can handle this infection. What did you do?
Well, my colleagues were pretty stunned when he was medevaced back to the U.S. that colistin, which is the last resort antibiotic, that this infection was already resistant to that. And when this drain slipped inside him and he became fully colonized with this bacteria, they basically said that there was nothing else that they could do.
That must have been incredibly scary.
It was just unbelievable. I remember just thinking that here I am, an infectious disease epidemiologist, and my husband is dying from what I used to consider a wimpy bacterium that I studied in undergrad days. I used to streak this bacterium on Petri dishes, and we had no, protective gear required. This is basically a bacterial kleptomaniac that has stolen all of these antibiotic resistance genes over the last couple of decades, and it's now considered to be the WHO's public enemy number one in terms of superbugs.
So without an antibiotic to overcome the infection, with your husband slipping away, you had to find some other way of dealing with this infection. What did you do?
Well, he was in a coma at this time, and I didn't even know if he could hear me, but I decided that it wasn't just up to me to decide that I wanted to kind of leave no, stone unturned. So this one particular day when his eyebrows were kind of, just twitching a little bit, I took his hand and I said, honey, I know that you've been fighting a long time and you may want to give up. And if you want to give up, that's okay. I'll let you go. But if you want to live, just, please squeeze my hand and I'll do whatever I can do to find something that will overturn this. And I waited, and a few minutes later, he squeezed my hand really hard, and I just took it as a sign. So I went home and I did what any, scientist would do. I went and Googled it and said, multi-drug resistant bacterial infection and alternative therapies. And using PubMed, which is the Google for Scientists version, I found a couple of papers that mentioned different types of treatments that had not yet been approved by the Food and Drug Administration. And one of these was phage therapy. And I knew what bacteriophages were because I'd studied them, 30 years ago in my microbiology class.
Now, you said phage. Could you spell that, please?
Yes, well, phage is Phage, but it's short for bacteriophage. So that's Bacteriophage. I feel like I'm in a spelling bee.
Yeah. And Dr. Strathy, what is a bacteriophage?
Well, a bacteriophage is actually a virus that has naturally evolved to attack bacteria. So they're actually the oldest and most populous organism on the planet. In a single drop of water, there can be millions or even billions of phages, and they're everywhere. They're not just in water. They're under rocks. They're in soil. They're on our skin. They're in our bodies. And if you're trying to fight a bacterial infection that's in your gut, then the best place to find the phages that attack those bacteria are in sewage. So that's actually where we found the phages that we used to treat Tom.
Well, before we get into the specifics of how you saved your husband, I'd like to turn to Dr. Aslam and ask you, it's almost as if this is the world's way of controlling what otherwise could be an explosion of bacteria.
That is very true. And actually, there have been a number of ecological studies done which show that the amount of bacteriophages, both within the human microbiome as well as the natural sort of geological niches, the amount of bacteriophages, outweigh actual bacteria by many fold. And so if we took into account, the viruses, bacteria, and fungi present in any landscape, the amount of viruses, which generally are bacteriophages, really outnumber the bacteria.
Well, it's so interesting because we tend to think of viruses as our enemies. They cause colds, rhinoviruses. Oh, they cause influenza. The number of viruses that are out there that make us sick scare us. And what you're saying is, whoa, wait just 1 minute. There are viruses, perhaps even in our digestive tracts, that are protecting us from bad bacteria.
Very true. And, it's not just the digestive tract, also our respiratory tract. So anywhere where we have microbiomes, and as you may know, the amount of organisms or bacteria in the human body is much more than actual human cells. And then if you add viruses to that or bacteriophages, they actually are even more than the bacteria. So it really is a fine balance.
Well, Dr. Strathy, so you looked in sewage to find a bacteriophage that would actually be capable of combating this Acinetobacter. How successful were you?
Well, it actually wasn't me that went picking through the sewage, thank God, but I did come up with the idea, so I'll take the credit for that. But I reached out to my colleague, Dr. Chip Schooley, who was then the head of our infectious disease division, and he was also a personal friend, and I said, Chip, it sounds like you guys are giving up and that there's nothing else that you can do. I've looked into some alternative treatments. What do you think of phage therapy? And he said in an email to me, what an interesting and intriguing idea, but it may be ahead of its time. But if you can find some phages that match his bacteria, I'll call the FDA and get approval for compassionate use, and we'll give it a whirl. So little did he know that it was really behind its time. Phages had been discovered 100 years ago and were being used and still are in the former Soviet Union. But I reached out to researchers all over the globe, and I found a handful that agreed to help. And one in particular at Texas A&M University agreed to be kind of the command center, where we sent him Tom's bacterial isolate, and he and his lab tested their whole library of phages and went through sewage samples to see if they could find any more that would be a precise match to the Acinetobacter baumannii infection that Tom had. We also had some help from the U.S. Navy, the Navy Medical Research Center in Frederick, Maryland, and they found some phages. So we had two cocktails that we were able to use to treat Tom, and luckily we got them in the nick of time.
You're listening to Dr. Stephanie Strathy, co-director of the UCSD Center of Innovative Phage Applications in Therapeutics. She co-authored The Perfect Predator, a scientist's race to save her husband from a deadly superbug.
You're also listening to Dr. Saima Aslam. Dr. Aslam directs UC San Diego Health's Solid Organ Transplant Infectious Diseases Service.
After the break, we'll find out how the phage therapy helped Tom Patterson recover.
What's the history of phage therapy?
How does it work to have viruses kill bacteria?
Where do FDA and Big Pharma stand on this revival of a very old treatment for dangerous infections?
We'll hear how phage therapy can be used synergistically with antibiotics to increase the likelihood of recovery.
You're listening to The People's Pharmacy with Joe and Terry Graydon. This People's Pharmacy podcast is brought to you in part by Verizana.com.
Verizana Lab offers home health tests that allow you to monitor your hormones and health conditions. You can take control of the quantitative assessment of your health and learn about male and female hormone balance, the stress hormone cortisol, leaky gut, gluten intolerance, or your gut microbiome.
Take a more active role in tracking your health and take 20% off your first order of a mail-in testing opportunity with the discount code PEOPLE. That's PEOPLE, all uppercase. To learn more, go to Verizana.com. That's VERISANA.com. Welcome back to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon. If you would like to purchase a CD of this show, you can call 800-732-2334. Today's show is 1155. That phone number again, 800-732-2334, or visit our website, peoplespharmacy.com. You can also download a free podcast from iTunes.
The People's Pharmacy is brought to you in part by Kaya Biotics, probiotic products made in Germany from certified organic ingredients. Kaya Biotics.com.
Today our topic is bacteriophage therapy, using viruses as a way of killing superbugs that resist antibiotic treatment.
We're talking with Dr. Stephanie Stradi, co-director of the UCSD Center of Innovative Phage Applications and Therapeutics. She's also Associate Dean of Global Health Sciences and Harold Simon Professor in the Department of Medicine at the University of California, San Diego School of Medicine. Dr. Stradi is an adjunct professor at Johns Hopkins and Simon Fraser Universities. She also co-directs the UCSD Global Health Institute and the International Core of the University Center for AIDS Research. She co-authored The Perfect Predator, a scientist's race to save her husband from a deadly superbug.
We are also talking with Dr. Saima Aslam. She is a board-certified infectious disease specialist. Her expertise is in caring for solid organ transplant candidates and recipients, as well as other immunocompromised individuals. Dr. Aslam directs UC San Diego Health's Solid Organ Transplant Infectious Diseases Service.
Dr. Stradi, you and your collaborators were able to find phages that matched up to the bacteria that were making your husband so deathly ill. How did that work in terms of helping him recover?
Well, we had two phage cocktails. One came from Texas A&M University, and one came from the Navy team. And the Texas A&M phages were ready first. And Dr. Chip Schooley and his team in the Division of Infectious Diseases here at UC San Diego put their heads together and consulted some experts. And they said, well, you know, nobody's really done this before in this kind of a way. So why don't we just administer the phages through these catheters in his abdomen that were draining off the infected fluid in his belly to see whether or not he can tolerate it. And if he lives through that, then we should go intravenous with the Navy phages because they were deemed to be more potent. And of course, I was terrified. I knew that there was a potential for Tom to die from septic shock because, again, you know, phages are sourced from sewage, and you do the best to, you know, spin off all of the debris that you can, but you don't really know how much of this endotoxin, as they call it, needs to be removed. So the first day that we did this was March 15th, 2016. It's seared in my brain. And we injected these phages into the catheters in his abdomen and put a buffer solution, which is basically a salt neutralizing solution, in afterwards because the phages need to be at a neutral pH. And then we clamped off the catheter and kept the phages in close proximity to the infection for about a half an hour and then let that clamp go. And, you know, the first day he seemed, you know, to be pretty stable, but he didn't get any better and he was still in a coma. So 2 days later, when the Navy phages arrived, and they were thought to be a much more potent, we injected those into his bloodstream. And that was one of the real innovations of my husband's case because nobody had used phages to treat a systemic bacterial infection going the intravenous route before, and we knew how risky it was, but he was on the verge of multi-system organ failure. His lungs were failing, his heart was failing, and now his kidneys were failing too. And I was told that he was going to need to start kidney dialysis any moment, and I signed the consent form for that, but we actually never needed the dialysis because he woke up from his coma 2 days later, lifted his head off the pillow, and kissed his daughter's hand.
What a relief.
It was a miracle.
It really was. It really was. And when you have doctors saying this is a miracle, you believe it.
Oh, my goodness. That is truly, truly amazing. Thank you so much for sharing that story. And Dr. Aslam, I wonder if you can tell us a little bit about the history of phage therapy in the Eastern Bloc.
And how do they work? This idea of having just one specific virus, one phage, to treat one bacterial infection, it's so targeted, it's so unusual.
Well, I'm happy to describe the history and also how it works. So in terms of, discovery of bacteriophages, the early discovery was initially described in a Lancet paper, I believe from 1915. And since then was actually used in the early 20th century for a variety of infectious syndromes. So there were sort of, cocktails as such for infections to treat dysentery, for example, as well as respiratory infections and pyogenic, furunculosis type infections. But in terms of it really taking off as therapy, and actually before I go there, the discovery of penicillin, around that same time, I think led to a decrease in the use of bacteriophages for these particular kind of infections in the West. During Stalin's time, there was a lot of interest in continuing to use bacteriophages, and the Eliava Institute in Georgia was set up at that time. And there are a variety of other institutes in Poland, as well as other places in Soviet Union, that continue to use bacteriophages, generally in an oral formulation, to treat similar sort of syndromes of infections. So not particularly matched initially for any specific bacteria, but for a syndrome such as dysentery or urinary tract infection, etc. In terms of how it works, bacteriophages are commonly used for a variety of applications in science. So these are very sort of small viruses in which there's a protein coat that's encoded or covers either a DNA or an RNA molecule. And it's shaped like a diamond, and there's a cylinder attached to that diamond with little fibers coming out. The fibers have specific attachment to bacteria, so it's that interaction between the bacteria and virus are very specific. And then the tail basically is a mechanism for the virus to inject its DNA or its RNA into the bacteria. Once that DNA is inside the bacterial host, it kind of hijacks the host's replication system and starts churning out multiple small viruses, which eventually can lead to killing of that bacteria, what we call lysis, and then releases thousands of viruses, in that medium, which then go on to infect other bacteria.
Dr. Aslam, the biggest problem, I suspect, in the world of infectious diseases today is antibiotic resistance. The bugs are winning the war. And once we run out of antibacterial medications, it becomes extremely difficult to treat these infections. Does resistance occur in the world of bacteriophage therapy as well, or is it just so specific that you can avoid this kind of problem?
So we're still learning about this, but unfortunately the answer is yes, resistance does occur. And we saw it occur in Tom's case, as well as other patients that we have treated at University of California in San Diego. And resistance can occur, of the bacteria to those specific viruses. At times, bacterial infections are not one specific bacteria, but maybe a few varieties of that bacteria. And so the virus may kill off, say subtype A, but then B and C will proliferate and continue the infection. So this is something we're still learning about, and in our future planned clinical trials and things, we are planning to, obtain more information and try to learn this systematically.
There's just one piece that I wanted to add here. In my husband's case, although resistance did develop and the bacteria became resistant to the initial phage, the Navy team was ready for this, and they were able to develop a second-generation phage cocktail within a couple of days, and they turned that around and sent it back to us, and that gave Tom and his bacteria the 1-2 punch. And so it's possible to actually, develop personalized phage cocktails very quickly, whereas if you have a bacteria that becomes resistant to an antibiotic and you've run out of antibiotics, it's going to be 10, 15 years or longer to develop a brand new antibiotic from scratch, where you can do with phages just right away.
Dr. Strathy, it's interesting that you mentioned the Navy, because it's my understanding that in the former Soviet Union, the Army was often sent off to war with bacteriophage kits. Is that true?
That's actually right. In fact, I know that Rommel's troops in Germany were found to have bacteriophage in their kits. And the Russians also had used phage in the war with the Chechens. So it's been extensively used in Eastern Europe. And that's one of the reasons why the West kind of forgot bacteriophage therapy. It wasn't just because penicillin came on the market, although that was a very important reason. There was also a geopolitical bias that if you were going to pursue phage therapy, that you were a pinko commie sympathizer.
And you probably didn't want to be that, not in the U.S. in the 1950s and 60s.
Yes. Well, in the 1940s in particular, that was when the death knell to phage therapy was delivered by a report in the American Medical Association. And that led to this being a forgotten cure until recently.
What was that death knell, Dr. Strathy?
Well, there was actually a series of reports that were commissioned by the American Medical Association, and they were published in the 1930s and 1940, I believe, was the last one. And they basically said, well, phage therapy might work for a staph infection, but there's no evidence of anything else. And when you really look at these reviews, they were incredibly biased. They only chose English articles. They only chose the negative articles. They picked 100 only, and they didn't look at any further papers after that. And those kinds of standards would just not hold up today.
I wonder how awareness of phage therapy might be encouraged in our current time.
Well, I think Stephanie's case and her husband's case was a big step here in the United States. And since then, actually, as I mentioned earlier, we've treated 5 more patients at UCSD. And we've been presenting our results at international as well as national meetings. And since then, actually, there's been a lot of interest. And I've helped sort of, in consultation with other patients at other hospitals and medical centers that are now using bacteriophage therapy for cases in which the infection is multi-drug resistant and they're running out of antibiotic choices. And some of these have been successful. Actually, most of them have been very successful.
What I find fascinating is that this is an approach that is now being used sort of as a last-ditch effort, as it was in Dr. Strathy's case with her husband, Tom. But it seems, from our vantage point, that this is a very promising area for future research. I wonder where the Food and Drug Administration stands on this and where drug companies stand on this, because some of the newer antibiotics are very pricey. Is this an opportunity that has yet to be developed, or are people still a little reluctant to engage in bacteriophage development?
I think it's an excellent question. Certainly, I think this is an opportunity whose time has come. And there is a lot of interest, both within the medical community as well as patients at large, in exploring this as perhaps a first line. So you mentioned the FDA. For the cases that we treated at UCSD and other places in the United States, the FDA has been incredibly helpful in getting approvals through, and sometimes over the phone or via email, and have been very supportive in pursuing this further as therapy. So right now we worked on what's called emergency INDs, or emergency sort of investigational agents, as we did in Stephanie's husband's case. But the FDA is actually very interested in seeing clinical trials come forward. And there are a variety of companies that are, either in the process of having bacteriophage product that we are using in these patients, or are interested in developing further.
Yes, in fact, there's one really exciting element of phage therapy that even if you take the absolute negative view that if a clinical trial was to get conducted and phage therapy wasn't found to be efficacious, we've seen in Tom's case and in several others that the phage and the antibiotics have actually been synergistic. So you can use phages to actually make a failing antibiotic work better.
Oh, that's really fascinating. I'm wondering, Dr. Strathy, Dr. Aslam, are medical students being taught about bacteriophage therapy? Because it seems like this has been an area that has not received much attention over the last several decades. Is it coming back in education so that your colleagues will actually be prepared for the future?
Yes, we are getting bombarded with requests, not just from patients and their families, but from students. We speak to students on a regular basis. We have volunteer interns at our new center, which is the Center for Innovative Phage Applications and Therapeutics, known as IPATH. So this is actually the first phage therapy center in North America, and we're happy to train the next generation. We see that as part of our mission.
I wonder if you can tell us briefly about IPATH.
Well, as you know, right now, phage therapy is still investigational. That means it's not a standard line of treatment in North America. And so our goal at IPATH is really to advance the science so that we can conduct clinical trials to determine whether or not it's efficacious on a broader scale. So that's what we're hoping to do in 2019, to conduct some small clinical trials in cystic fibrosis patients. My colleague, Dr. Aslam, is actually hoping to launch a clinical trial herself.
Yes, so I actually am submitting an IND to the FDA this week. Our goal is to treat patients with ventricular cyst devices that are infected and use bacteriophage therapy as an adjunct to IV antibiotics. And we're very excited. This would be a pilot trial, as would be the cystic fibrosis pilot trial, and get some preliminary data to conduct randomized control trials in the future.
Dr. Aslam, have you been consulting some of the researchers in Georgia? And when I say Georgia, I'm not talking about, Georgia, U.S. I'm talking about Georgia in the former Soviet Union, and researchers in Poland, because presumably they've been continuing to research this over the last several decades.
That is very true. I think they are continuing to research this and publish this. Personally, I have not spoken to any of the researchers there, but I think Dr. Strathy actually has been in touch with those centers.
Yes, I have.
And are they encouraging you?
Oh, absolutely. And unfortunately, there's so many patients that, we don't need to compete. We're in this together. And certainly there was actually an investigator who was trained at the Ilyav Institute who consulted on Tom's case. So at the phage institutes in Georgia, they tend not to treat intravenously. And we're hoping to trade information with them and vice versa.
You're listening to Dr. Stephanie Strathy, co-director of the UCSD Center of Innovative Phage Applications and Therapeutics. She co-authored The Perfect Predator, a scientist's race to save her husband from a deadly superbug.
You're also listening to Dr. Saima Aslam, a board-certified infectious disease specialist.
After the break, we'll hear how phage therapy can be used to help transplant patients.
Find out about potential side effects of phage therapy.
What do these experts see as the future of bacteriophage therapy?
You're listening to The People's Pharmacy with Joe and Terry Graydon.
The People's Pharmacy podcast is sponsored in part by Kaya Biotics. KAYA Biotics offers the first probiotics which are both certified organic and hypoallergenic.
All probiotics are produced in Germany under laboratory conditions with high-quality ingredients and under strict regulatory oversight.
The 3 available formulas are created for very specific purposes, such as strengthening the immune system, fighting yeast infections, and helping with weight loss.
To learn more about Kaya Biotics probiotics and the important topic of gut health, you can visit their website, KayaBiotics.com. That's Kaya Biotics.com. Use the discount code PEOPLE for $10 off your first purchase. Welcome back to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon. To purchase a CD of today's show or any People's Pharmacy broadcast, you can call 800-732-2334. Today's show is 1155. That number again, 800-732-2334. You can also download the free podcast from iTunes or from our web store. We invite you to consider writing a review.
The People's Pharmacy is brought to you in part by Kaya Biotics, probiotic products made in Germany from hypoallergenic organic ingredients. Kaya Biotics.com.
Today we're discussing the modern application of a very old type of therapy in which viruses are enlisted for killing superbugs that no longer respond to antibiotics. It's called bacteriophage therapy.
Dr. Stephanie Strathy is co-director of the UCSD Center of Innovative Phage Applications and Therapeutics. She's also Associate Dean of Global Health Services and Harold Simon Professor in the Department of Medicine at the University of California, San Diego School of Medicine. Dr. Strathy is an adjunct professor at Johns Hopkins and Simon Fraser Universities. She also co-directs the UCSD Global Health Institute and the International Core of the University's Center for AIDS Research. She co-authored The Perfect Predator, a scientist's race to save her husband from a deadly superbug.
You're also listening to Dr. Saima Aslam. She is a board-certified infectious disease specialist. Her expertise is in caring for solid organ transplant candidates and recipients, as well as other immunocompromised individuals. Dr. Aslam directs UC San Diego Health's Solid Organ Transplant Infectious Diseases Service.
Dr. Aslam, I understand that you have been using some phage therapy to treat heart transplant and lung transplant patients. And of course, when a person gets a transplant, they also have to take immune system suppressing drugs so they don't reject their transplant. This puts them at risk for infections. Is that why the phage therapy is being used in such patients?
I think it's a really good question. We've actually used it. So pre-heart transplant, we had 2 patients that had what's called a ventricular assist device that were infected. Both of them got transplanted after completing phage therapy. The patient that we treated in immunosuppressed setting was actually a lung transplant patient. And then there was another patient I treated that had cystic fibrosis who was awaiting lung transplant. So, going back to your immunosuppression risk, definitely when people have immunosuppressive medications that cut down their immune system, that it increased risk of infections. For our lung transplant patient, and this is true of most lung transplants, that it increased risk of a particular infection called Pseudomonas aeruginosa. And this tends to be very drug resistant. And so in this particular case, he had Pseudomonas pneumonia many times following lung transplant and actually had been unable to leave the hospital, 6 to 8 months later and was still in the hospital and in the ICU setting.
Oh, my.
So he was very sick and on a ventilator for months. But each time we treated the Pseudomonas, it got more and more drug resistant, and we were running out of options to treat him. And so it's that time that we decided to use bacteriophage therapy, again as an adjunct to IV antibiotics. And in this case, we actually gave it to him both intravenously, but also directly into his lungs. He tolerated both very well and actually recovered from his pneumonia. And part of doing it into the lungs and the IV was to assess if there was any benefit to doing one versus the other. In both cases, the bacteriophage got to where it needed to be and, was starting to replicate and eat up the Pseudomonas. But after that case, we've used it intravenously. And in one patient was completely as an outpatient. He was actually never admitted, and he injected it to himself at home every day. After receiving the first injection in clinic, that was overseen by me. And we've been successful in that as well. So I think, we've come a long way from the first time we used it just, 2 years ago to now treating an outpatient who's injecting himself with bacteriophage therapy.
How do you source the bacteriophage so that it matches up to the bacteria that's causing the problem?
So, we get samples from the patient, so samples of their bacteria, and we've been collaborating with both the Navy. That was the first one with Dr. Strathy's husband, but also with a local company called Amplify Biosciences. We're also now interested for future patients to collaborate with academic laboratories in which researchers work with bacteriophages. But basically, the bacterial isolate is sent to wherever we're trying to source the bacteriophage from, and they run tests to see if the bacteriophage they have would kill the bacteria that we want killed.
Now, I can imagine there are health professionals listening to your voice right now, Dr. Aslam, and patients and their families, and there may be situations where someone is in septic shock this very moment on death's doorstep, and people are going, wait a minute, I would like to get access to a bacteriophage that might be the cure for my loved one. How do physicians or patients or their families interact with your organization or other organizations to perhaps explore this possibility?
I think that's also a very important question. And these are sort of the queries that we handle at IPATH. But ideally, the infectious disease physician taking care of such a patient can get in touch with us or family members, and we help sort of direct the path based on what bacteria it is, and help find researchers or commercial laboratories where they can send their bacterial isolate to be tested against specific bacteriophages.
Dr. Strathy, this is a race against time. You had personal experience with that. I could imagine a day when you would be inundated with requests from all over the country and perhaps even all over the world.
Oh, that's already happening. My husband's case was actually publicized in April of 2017, so almost a year after he was cured. And the moment that it kind of went viral, literally, I started getting calls, first from China, then Malaysia, Germany, the UK, Canada, Australia, New Zealand, all over the United States. Thank God we have IPATH now because we actually have at least a single staff person to help. But it's actually there's a huge need, and we actually are hoping to help more physicians and health centers around the world have this experience because we really see this as a potential solution in conjunction with antibiotics.
And Dr. Aslam, you've mentioned that the FDA has been quite cooperative, although it's my understanding that at this point no phage therapies are approved by the FDA. They have been helpful in your efforts. Do you anticipate that will continue?
Oh, yes, definitely. So they've been very helpful in terms of emergency use of bacteriophages, so in individual patient cases. And they're very interested in us and other researchers developing clinical trials so that it can be, shown to be effective in a scientifically sound manner. And, that is what would lead to FDA approval. But they've been actually helping us throughout this process and how best to achieve that.
Dr. Strathy, you are co-director of UCSD's Center for Innovative Phage Applications and Therapeutics, IPATH. How would someone get in touch with your organization?
Well, it's as simple as a phone call or an email. Email is easiest these days, so you can email ipath@ucsd.edu, and we're there standing by 24 hours a day, or at least I am, because I'm the one getting a lot of the calls.
Dr. Strathy, you have co-written with your husband, Tom Patterson, The Perfect Predator, a scientist's race to save her husband from a deadly superbug. So, as your co-author, he actually was in a coma for a great deal of what transpired while you were racing to save his life. What is his perspective?
Well, Tom was actually in and out of a coma for most of the duration of the time that he was being treated, but he had very vivid hallucinations, and he'd be the first one to say that if you're in a coma, it doesn't mean that you can't hear. You're not a loaf of bread. He recalls me asking him if he wanted to live and squeezing my hand. He recalls doctors speaking about him while he was there as if he couldn't hear. And he has these incredible journeys. He believed that he was in the desert wandering for 100 years and met 3 holy men who asked him questions about life and death. And he dictated these to me, and they're in the book for everyone to read. For me, that's my favorite part.
That's quite extraordinary. I guess there's a lesson here for family members and health professionals. As you say, just because someone's in a coma doesn't mean they're not aware of what's going on around them.
Absolutely. I think the first time we presented our case at Grand Rounds at UC San Diego, and Tom said, "I could hear you." All of the audience was just full of physicians, went, "Ruh-roh."
Uh-oh.
Oh, my goodness.
That's wild. How has he changed as a result of this amazing journey he has been on?
Well, I think that he has learned to, seize the day and live life to the fullest. He hasn't stopped his intrepid traveling, so we've gone back to Africa even, and he's a lot more, I think, wise and is, I think, just happy to be alive. He was promoted to be a distinguished professor by his department this past year, and he calls himself the nearly extinguished professor.
Dr. Aslam, and before we conclude our conversation with you both, there are just a couple of things I need to ask. Anytime we talk about a new therapy, or in this case, a new old therapy, I need to ask about side effects. Can you tell me what are the potential side effects that your patients may experience?
Yes, definitely. So the main side effect that we worry about, and at least I have not seen in any of my patients, is related to the endotoxin content. So the bacteriophage cocktails used in Tom were, as she mentioned, cleared out from sewage. But with that, there certainly is concern for an allergic type reaction, or what we call anaphylaxis, as well as septic shock. However, the commercially available products currently available, as well as the commercial grade products we're now expecting from research laboratories, do not have endotoxin actually. And so there is no side effect related to that at all. One of my patients described his side effect, which he described as getting better day by day. And that was his most notable side effect. So, I think when we talk about potential adverse events, we monitor our patients very closely, and thus far have not come across anything that would deter us from pursuing this further. But when we do our clinical trials, we'll be looking out for side effects.
Dr. Aslam, what would be some of the most common bacterial infections, especially those that are hard to treat because of antibiotic resistance, that you're looking forward to dealing with in terms of bacteriophage therapy?
So certainly, multi-drug resistant organisms, and this would include things like Pseudomonas aeruginosa, E. coli infections, Klebsiella, Acinetobacter baumannii, as well as MRSA. These are current organisms that we're interested in.
MRSA, also known as methicillin-resistant Staphylococcus aureus, is a very hard-to-treat condition, and it's pretty widespread. Is there hope that there might be bacteriophage therapy against MRSA?
Yes, there's always hope. And in this case, we have a couple of candidates that we want to test in clinical trials and hopefully demonstrate that it works.
We have just a couple minutes left, and I'd like to ask each of you what you envision for the future of phage therapy.
Well, I can start. I think that phage therapy is going to enter clinical trials in 2019. I think it will take us a couple of years to establish whether or not it's efficacious. And based on what I've seen, I'm very hopeful. So I'm hopeful that phage therapy will be offered alongside antibiotics to treat multi-drug-resistant bacterial infections in the future. And it's going to be a very important weapon.
So to add on to that, I definitely agree with Stephanie's assessment. I do want to say that in addition to multi-drug-resistant organisms, I think we'll be seeing, hopefully, use of bacteriophage therapy for device infections, regardless of whether the bacteria is drug-resistant or not. Currently, device infections are very difficult to clear with antibiotics because they have a slime layer on them that the antibiotics do not penetrate. But we have scientific evidence that bacteriophages actually penetrate this slime layer very well. And so one of our planned trials is for device infections and using bacteriophages as a way of getting rid of that slime layer.
And what kind of devices are you talking about?
So I think the interest is in cardiac devices as well as orthopedic devices currently.
And what about mesh? We've heard a lot of problems associated with hard-to-treat mesh infections.
I think that certainly would be a possibility. The difficulty with mesh infections is that they tend to be polymicrobial, meaning it's not one bacteria causing that infection, but multiple. And at this time, I think our goal is to really focus on single organism infections, as the bacteriophage is very specific, but potentially in the future.
Dr. Aslam, Dr. Strathi, again, can you tell us how people can get in touch with IPATH and the folks at University of California, San Diego, who are at the cutting edge of this research?
Sure, we're just one email away. You can email us at IPATH, that's IPATH, at ucsd.edu.
Dr. Stephanie Strathi, Dr. Saima Aslam, thank you so much for talking with us on the People's Pharmacy today. It's been fascinating.
You're welcome.
Thank you very much.
You've been listening to Dr. Stephanie Strathi. She's Associate Dean of Global Health Sciences and Harold Simon Professor in the Department of Medicine at the University of California, San Diego School of Medicine. She's co-director of the UCSD Center of Innovative Phage Applications and Therapeutics. She and her husband co-authored a memoir, The Perfect Predator, a scientist's race to save her husband from a deadly superbug.
You also heard from Dr. Saima Aslam. She's a board-certified infectious disease specialist. Her expertise is in caring for solid organ transplant candidates and recipients, as well as other immunocompromised individuals. Dr. Aslam directs UC San Diego Health's Solid Organ Transplant Infectious Disease Service.
Lynn Siegel produced today's show. Al Wodarski engineered. Dave Graydon edits our interviews.
The People's Pharmacy is produced at the studios of North Carolina Public Radio, WUNC.
The People's Pharmacy theme music is by B.J. Liederman.
To buy a CD of today's show or any other People's Pharmacy broadcast, you can call 800-732-2334. Today's show is 1155. That number again, 800-732-2334, or you can find it on the website, peoplespharmacy.com.
When you visit our site, you can share your thoughts about today's show. Have you had experience with an antibiotic-resistant infection? We'd love to hear your story. If you have ever encountered bacteriophage therapy, we'd be interested in that too.
We also have links to the IPATH website and to their email. At peoplespharmacy.com, you can sign up for our free online newsletter or subscribe to the free podcast of the show. You'll never miss another episode again, and you can share it with a friend.
And when you sign up for our newsletter, you'll get our free e-guide to favorite home remedies.
In Durham, North Carolina, I'm Joe Graydon.
And I'm Terry Graydon. Thanks so much for listening. Please join us again next week.